All right, so we're going to look at 6B support real quick. And let's see, there's 4 questions in here. They want us to sort of know this to get us prepared for the actual 6B lecture. So question number 1 wants us to evaluate the square root. And they're giving us the square root of 9. All right, so any of y'all know the square root of 9?
3.
That's it. Okay, so the square root just undoes those exponents when you squared stuff. Okay. All right, number 2. They're giving us the waiting times at a big bank. So this is the big bank waiting times. So it must have been how long they was in line before they actually got to the teller. So they want us to find the mean and median. All righty, so the waiting time was 4.1, 5.2, 5.6, 6.2, 6.7, 7.2, 7.7, 7.7, 8.5, 9.3, and 11.0. I'll put commas between all those. Okay, so let's see, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times that they measured. And we're happy they put these in order, because if they didn't put them in order, I would have to put them in order when I found that median, okay? So let's see, the first thing they want us to do is find that mean. So here we go, we're going to find their mean. Now remember, the mean is the sum of all values divided by the total number of values. So that bottom we said was going to be 11 because I had 11 different times. So what we got to figure out is the sum of all values on the top. So we're going to bring out the calculator to do that. So we got 4.1 plus 5.2 plus 5.6 plus 6.2 plus 6.7 plus 7.2 plus 7.7 plus 7.7 plus my 8.5, my 9.3, and then my 11.0. So the sum of all those, when I add them all together, is 79.2. So the top of this equals 79.2. Now the number of values we said, I think we said 11, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 of them. So that's why we're going to divide by 11. So let's take that 79.2, divide by 11, and that's going to give me 7.2. So y'all, the average of my 11 numbers was 7.2. All right, they want me to round that one decimal place, which is what it ended up which is what it ended up as, so we're good on that. So now we need to get our median. So remember, since this is an odd number of data entries, I need to find the exact middle number. When it's even, you gotta average the two middle numbers, but y'all, since this is odd, I need to find the very middle number on that. So when I got 11, so I need 5 on each side. So 1, 2, 3, 4, 5. My median will be number 6, and then that leaves 5 numbers to the right. So I'm exactly in the middle. So I picked the middle number. Which was 7.2. So then what they wanted you to compare was the mean and median on this. Well, my mean was 7.2. My median was 7.2. So for this one, my mean was equal to the median. So remember, actually, if you wanted to figure out what kind of graph this would be, remember when they were equal on your little curve, when the mean and median were equal, it was totally symmetric. Remember, if the mean was less, it would be left skewed, and if the mean was greater than the median, it would be right skewed. But when they're equal, you got a perfect symmetrical bell curve. So that, y'all, they just wanted us to review a little bit about the mean and median because we did that in 6A. So the big thing that you're learning new in 6B is what we call the standard deviation. So for number 3 here, they want us to find the standard deviation. And then we'll sort of talk about this in the actual 6B lecture. They just wanted me to show y'all a problem actually doing it before we hit the chapter so that you could understand what we was talking about on that, okay? So let me write my data down. My data is 11, 12, 12, 11, 20, 17, 10, 17, and 6. So I should have 9. So I got 9 entries. So I got 9 entries. Okay. So I'm going to pull my camera down a little bit so I can get all this on here. So I'm going to make a column I call X. X will be each one of these data points. I'll then make a column that says X minus the mean. So we're going to figure out what X is minus the mean we get. Then I'll have a column that says X minus the mean squared. So whatever answer we get in this column, to get to this column, we're going to square it or multiply it times itself. Okay. So once we get all this data over here, our standard deviation is going to equal the square root of the sum of my X minus mean squareds divided by n minus 1. So n is the number of entries you got. So for my problem here, n is going to equal 9. So that's going to equal n for these, okay? So this says standard deviation is the sum of what I get for these x minus mean squareds. I'm going to add all that roll up. That's going to give me my sum, and then I'll divide it by n minus 1, and then take the square root of that answer. So the square root's really the last thing you do to it. Figure out and that's what this chart's going to do. By the time we're done with the chart, we'll have the sum of the x minus mean squared right there, okay? So y'all, let me show you. These ain't as bad as all this stuff I'm talking, okay? So here we go. Let's write our x's down. That's all these datas. So 11, 12, 12, 11, 20, 17, 10, 17, and 6. I'm going to pull that down a little bit more. And then down here, I'll make the line going across. So x minus mean. So the first thing we got to do is actually find our mean. So our mean is going to equal all of these added together divided by 9, because I had 9 entries. So y'all want to bring the calculator here. I'm going to add that column up. So turn it on. So 11, 12, 12, 11, 20, 17, 10, 17, and 6. So that whole row added up gave me 116. So my mean is going to equal that 116 divided by 9, because that's how many entries I had. So y'all, let's take that 116 divide by 9. That's going to give me 12.888. They want me to round 1 decimal place. So I'm going to round that to a 12.9. So our mean is 12.9. So this column right here says x minus the mean. They want me to take each one of these x's and subtract my mean, which is the 12.9. So some of these are going to end up negative and some of these are going to end up positive. So it's always the x11 minus 12.9, which was my mean. That gives me a negative 1.9. Then I do the next one. 12 minus 12.9 gives me a negative 0.9. So the next one's going to give me a negative 0.9 because it's the same. 11 I already did. That's a negative 1.9. So once I get around repeats, I'm sort of good to fill in for those. Now I got 20 minus 12.9. That's going to give me 7.1. 17 minus 12.9. That's going to give us 4.1. 10 minus 12.9 gives me negative 2.9. So any of these numbers that are smaller than the mean is going to give you a negative number. Any numbers that are bigger than the mean will give you a positive number here. All right, 17 we done did. That gave me 4.1. And then 6 minus 12.9 gave me a negative 6.9. So this tells me how far each one of these points was away from my mean, which was 12.9. So like this one was 1.9 on the other side. This one was a 0.9 on the other side. You get down to this 7.1, that's how far on the right side it was, or how much bigger it was. 4.1, how much bigger that one was. So the signs almost tell you, are they less than or greater than your actual mean, okay? So now, the reason we're squaring all of these is because when you square a negative times a negative, you get a positive. So all these numbers are going to turn positive when you square them. And you better put the negatives inside your parentheses. So watch how I do this. I'm going to square this negative 1.9 by putting it in parentheses. Negative 1.9. Close the parentheses. And then you can hit this X squared button over here to square it. And when I do that, I get 3.61. So you better be multiplying the negative times the negative when you got negative numbers. That's why I'll always put my negative numbers in parentheses. So watch this. Negative 0.9, those parentheses, and square that. I get 0.81. I'm going to get 0.81 again. Negative 1.9, I know that's going to give me 3.61. All right, 7.1, square that, and I get 50.41. So y'all notice, if it's a positive number, I don't need parentheses. I mainly need the parentheses for the negative numbers, okay? All right, 4.1, square that, 16.81. Negative 2.9, I'm putting my negative 2.9 in parentheses, closing parentheses, and then squaring that. I get 8.41. 17 is going to give me 16.81. Done did it up there. And in parentheses, negative 6.9, close parentheses, and square it. 47.61. Now, watch what happens if you do negative 6.9 and you square it without the parentheses. It keeps it negative. That's why you got to put those negatives in parentheses. Anything times itself is going to give you a positive sign, okay? All right, so what we do want right here, we want the sum, because that x minus mean squared is all these numbers. And remember, in my formula, I needed the sum of all of those. So I'm going to add this row of numbers all together and see what that equals. So let me clear everything. So 3.61 plus 0.81 plus 0.81 plus 3.61 plus 50.41, 16.81, 8.41, 16.81, and then 47.61. So let's hit enter and add all them together. Looks like I got 148.89. Okay, y'all, so all these added together gave me 148.89. So now we have everything we need to fill out this formula. So our standard deviation is going to equal the square root, the sum of x mean squareds, x minus mean squareds is that number we just found right here. So this sum will now go to the top of that fraction inside the radical. So that was 148.89. Now remember, n minus 1, n is the number of data entries I had, which was 9. So I'm going to take 9 minus 1, and that's going to give me 8. So now your calculator will be able to do everything at once. So start out by hitting the radical sign. So the radical is right above that little x squared key, that little blue bar. So hit the blue button and the x squared key, and that's going to bring your little square root up on there, okay? So then on the top, we had 148.89 divided by our bottom, which was n minus 1. So when I say 9 minus 1 made that bottom a 8. Now notice, everything's got to be up under that radical for this to come out right, okay? You don't want to put the first part in the radical and then the dividing and stuff on the outside. It's all got to be up under that radical. So we hit enter, and we will now have our standard deviation. So let's see, they want me to round that 1 decimal place. So I got what, 4.31. So since that's 1 after the 3, I'm going to keep that at 3. So our standard deviation is 4.3. So y'all, that was number 3. And I'm going to do another one of these because support has 2 of these to do, okay? So let me let y'all write that for a second. So y'all, really, it's not bad. It's just you got to keep up with your little charts we're making for the x minus the mean, x minus mean squared. And then remember, add that whole row up to get the sum. Once you finally got that sum, then you throw it into the formula. So y'all, you now see the main thing that 6B is going to be working with. All right, so let me find the top of this again. So we're going to do the same thing, and then we'll get into that 6B lecture. We're going to find the standard deviation. And remember, that standard deviation was the average of all the deviations. The deviations were the x minus mean part of it. Okay. So basically, your standard deviation is really just finding their average in a way. Okay. All right, let's see. 1, 2, 3, 4, 5. 1, 2, 3. Looks like 6 data entries here. So I got 20.3. 11.2, 36.1, 34.3, 11.8, 21.8. And they're not really telling me what these are. They just want us to find that standard deviation. So I'm gonna start out by making my chart. My x's, my x minus my mean, my x minus my mean squared. Okay. And then remember, our formula is going to be standard deviation equals the square root, the sum of our x minus means squared divided by n minus 1. When I say we had 1, 2, 3, 4, 6 of these. So here we go. Write our x's: 20.3, 11.2, 36.1, 34.3, 11.8, and then 21.8. And remember, I'm going to add all these up, divide by 6. So my n is going to be 6 this time. And I had 6 datas, okay? So let's add all that up so we can find the mean. So here we go, 20.3 plus 11.2, whoops, 36.1, 34.3, 11.8, 21.8, add it all together, gave me 135.5. So my mean is going to equal 135.5 divided by 6. So I had 6 data values. So let's take that and divide by 6. That gives me 22.58. So I'll tell you a trick I do. I'm going to keep the 8 because I always go one more place than what they do. So since they're rounding one place, I'm going to round 2 until my final answer. All right, so here's the thing. I got all my x's. I know the mean. So now I'm going to take every x minus that mean of 22.58 and get this column. So here we go. 20.3 minus 22.58 negative 2.28. So remember, they'll be negative and positive in this row, but once I square them all, they're going to become positive. All right, so 11.2 minus 22.58, negative 11.38. 36.1 minus 22.58, 13.52. 34.3 minus 22.58, 11.72. So once again, all the ones bigger than the mean are positive. All the numbers that were smaller give you negatives, okay? 11.8 minus 22.58, negative 10.78. 21.8 minus 22.58 gives me negative 0.78. Now, I'll tell you, if you're doing these on your own, what I do, if I'm doing it on my own, I do the 20.3 minus 22.58. That's going to give you negative 2.28, and then negative 2.28 squared gives you 5.198. So I'm going to round that to a 5.20. But you can do them sort of as you do each row, okay? But I'm just going to do them like I did it a while ago. So negatives, I'm going to put in parentheses and then square them. So I get 129.50. So I'm going to make that 129.5. 13.52 squared. 182. We'll make that 182.8. 11.72 squared. 137.4. All right, these two are negative, so I'm going to put them in parentheses. So negative 10.78, those parentheses and square. 116.2. And then parentheses, negative 0.78, those parentheses and square. I'm just going to call that 0.6. All right, so add all these together, and that's going to be our sum. And that's what we're going to put on top of that radical, okay? So we're going to add these up. They're all positive. So 5.2 plus 129.5 plus 182.8, 137.4, 116.2, and 0.6. All of them added together gave me 571.7. All right, so get ready for your formula. That's going to equal the square root this 571.7 is going on top again. Okay, so here we go, 571.7. On the bottom is n minus 1. We said we had 6 of these. So 6 minus 1 would make that a 5. So we're ready to take this square root. So the first thing you do, get your square root. So second x squared. So do you notice the same button I square with is the same button I use to square root with? I just got to hit the blue one first. All right, y'all, what did I have on top? 571.7 divided by what I have on the bottom was my 5. So all that's under the radical like it needs to be. So I hit enter, and I'm going to round that 10.69. So they went 2 decimal places, so I'm going to make that a 10.69. So what that really tells me, if you look at all this data over here, it tells me that average distance from the mean was about 10 places, no matter which direction, okay? Now, some were pretty close, but then some were sort of spread out more, like the 36 and the 34. They sort of brought it out a little bit, okay? All right, y'all, so that was just support. So, y'all think y'all ready for that, tackle that standard deviation? All right, y'all, so let's go to 6B lecture. All right, let me get this paper right. And we'll actually learn all about standard deviation again officially in this chapter on 6B. They just wanted me to show you how I'm doing it so that when I actually explain it, you know what's going on, okay? So 6B deals with measures of variation. How much does my data vary from each other away from my mean? Do I got a lot of variation because numbers are pulling it way left or right? Most of my numbers, are they more in the middle? Okay, so that's why they study variation. 2 schools can have the same scores on a gateway exam, but 1 school, most of the scores could have been right around 75 or so with a little bit of variation. But then the other school, although they had a 75 average, they had scores that were very low and very high. Okay, so they had more variation. So just the mean itself or the average does not tell you enough to tell me whether all students are succeeding or if I got an issue and I got very high students bringing the average up for my low students, okay? So we try to get our variation to be as small as possible. So we're going to start with definitions. So we're going to look at the range. So in statistics, the range of a data set is the difference between its highest and lowest data values. So here we go, formula. Range equals highest value, which you can call your max, minus your lowest value, which we can call our min. So the max point minus the min point gives you the range. That's how wide your data is, okay? All right, so that gives me two numbers. That gives me a high number, and it gives me a low number. And then the range is the difference between them, okay? So let's look at what we call quartiles. So y'all, guess what? A quartile sort of splits it into 4 sections, right? So these sections are going to be the lower quartile, so the lower quartile is the lowest end, and it divides the lowest fourth of data. So it divides the lowest fourth of data from the upper 3/4. So you're basically, it's cutting that bottom fourth off from the other 3/4. Okay, you got 3/4 above it, 1/4 below it. Now, to find the lower quartile, it's a median in the lower half of the data. So we're going to find the actual median. Remember, the median splits the overall data in half. So the lower quartile, you take all the data points up to the median, and you find their median for that lower quartile. So then you have the middle quartile. So we had our lower quartile. Now we got our middle quartile. It is basically just what I said. It's the median of the entire data set. So the median of the entire data set. And you can also call this the first quartile. This could be the second quartile. And the one I get next could be known as the third quartile, okay? So whether you're using, so this could be the first, this could be the second. And then we got the, so I had a lower quartile, middle quartile, next is the upper quartile. And basically, what does it do? It divides the lower 3/4 of the data from the upper fourth. So, y'all, it basically does what the lower quartile is doing with the bottom fourth. It's doing the same thing with that top fourth, okay? And this could be what, the third quartile. I usually just use lower, middle, and upper, but you could use first, second, and third quartiles, okay? So check this out. The range gives me two numbers. It gives me the high and the low. The quartiles give me the under three numbers, the lower quartile number, the middle quartile number, and the upper quartile number. So this gives us what we call the 5-number summary. And it consists of the following numbers. It's got a low value. It's got a lower quartile. It's got the median. Now remember, the median's over all the data. I got an upper quartile. And then I got my high value. That's my five number summary. So I'm gonna let y'all copy that real quick and then I'll turn that, okay? Let me pull that side down. All right, so the main things is the high and low values or the range and those three quartiles, okay? So what we're going to look at next is what we call a box plot. Okay, also, let's look at a box plot. So a box plot shows the 5-number summary visually. With a rectangular box. Enclosing the lower and upper quartiles. The line marking the median. So that line will be inside that rectangular box, okay? The median will be inside that rectangular box. And then whiskers extending to the low and high values. So I'm going to draw you what we're talking about. So I got me a rectangular box here. The ends of the rectangular box, this right here is my first quartile. This line right here is your third quartile, or lower and upper. Remember, this could be your lower quartile, your upper quartile. So I'll call that lower and upper. You got a line in here anywhere, it just depends where that median is, but this one is your median. Or it could be what, your second quartile. All right, now when I'm talking about whiskers, I got these whiskers coming out here with their little bars. Then that little bar right there is the low value. And then this value over here is the high value. So they call it a box plot, but it's a box with whiskers, they'll call it too, okay? Because it looks like it's got little whiskers coming off of it. So the overall median is the center of the box or inside the rectangular box. You got your first quartile or your lower quartile, your third quartile, which is your upper quartile. Remember, that's the median of this data. The first quartile is the median of the first half of data, okay? So overall data median, this side first quartile, this side's median, third quartile, and then you put your low and high values. All right, y'all. So then let's see, I got enough time. We're going to sort of talk about standard deviation again. And it's probably the single number most commonly used to describe variation. So the single number most commonly used to describe variation. So remember, variation had different effects. If there's little variation, remember the graph, if it had a little variation, that graph sort of went up. So that was a little variation. So most of my scores are right around my median. But remember, if it had a lot of variation, it sort of flattens those graphs out a little bit, okay? So this would be high variation. Might have had the same average, but you had a lot of low scores being counteracted by high scores. So in this one, you had the same average, but most of the people were making that same average, okay? There's all around that 75 versus you had low scores over here, okay? So more of these students would have been prepared for college versus these students, because some of these students were sitting over here in the 10, 20, 30% range, okay? So standard deviation is what we say the single most commonly used number to describe it, okay? So your standard deviation equals, I'm going to have to write this right here, the square root, the sum of deviations from the mean squared. So that's when I was doing that x minus x bar, remember? I had to add all of those up. That was the sum of all of those. And then remember, we divided that by the total data values minus 1. So we added up how many data points we had, subtracted 1 to get the bottom. And then we took the square root of all that, okay? All right, y'all, so I'm going to actually give you the steps to finding that standard deviation of doing what we just did. So let me see. So y'all got this? I'm going to go to more notes then. All right, y'all, so the standard deviation is calculated by completing the following steps. All right, so what was the first thing I do? Remember, I wrote all my data points down. So the first thing I did, I had to find the mean. So I compute the mean of the data set. Then find the deviation from the mean for every data value. All right, so when I was doing that, remember, that was the stuff where I was doing the x minus the mean. Okay. I had that second column, x minus the mean. That's what they're doing. That's what they're talking about on all of that. So once I had all them numbers, they wanted me to find the squares of all the deviations. So find the squares of all deviations. So when we was doing that, that was this part where I said, okay, x minus the mean squared. So that was that third column of numbers we was making. So then I said, find the sum of x minus mean squareds. So you took that whole column and we added them all together and got that number. So next, we put that number under that little radical. So we was doing what? We was dividing that number. So divide the sum. So divide that sum by the total data values minus 1. So this stuff was the n minus 1, okay? The values minus 1 was the n minus 1 part of it. So then what did we do? The last thing we basically are doing, we took the square root. So take the square root and get the standard deviation. Now let me kind of hold that down. Now y'all got that part? So let me see. All right, y'all, there's one more thing I'll talk about. And this is sort of like more definition type stuff. And then next class, what we'll do, we're going to sort of work through those 6B EMR homework problems. So today I mainly did the support. So tonight you'll be able to do the support for sure. And you could probably do part of the actual 6B homework. But I actually will go through 6B deeper into homework problems on next class. So the last thing I want to show you is what we call the range rule of thumb. So the first thing they look at, the standard deviation. is approximately related to the range of a distribution by the range rule of thumb. They say that the standard deviation equals, not equals, but it's approximately equal to the range divided by 4. So they're saying, hey, if you know the range of your data, which is the difference between the high and low numbers, if you know that range, then divide by 4 and you will approximately get the standard deviation. Might not equal it, but it'll get close. It also goes the other way. If we know the standard deviation, for a data set, we estimate the low and high values by, so if I know the standard deviation, so say my mean is 10 and my standard deviation was 2. So here's a mean of 10 sitting right here. Each standard deviation in each direction. So I said my standard deviation was 2. So my standard deviation is 2. So from 10, if you go to the right, your next number would be 12. That would be 1 standard deviation to the right because I added 2, which was my standard deviation. If I add 2 more, so if I add 2 more, that would put me at 14. So this is 1 standard deviation, 2 standard deviations, and I can keep going and so on by increments of 2 because that's what the standard deviation is. If you go to the left, 10 minus 2 would put that at 8. If you do another standard deviation, minus 2 would put me at 6. So 6 and 14, both of those numbers are 2 standard deviations from my mean of 10, okay? So that's what they're about to mean by this. To get the low value, that's approximately equal to the mean minus 2 times the standard deviation. So what that means by 2 times standard deviation is what I was showing you. So the low number, you take the mean, which is 10, minus 2 standard deviations, which are 2 each. So 2 and 2, so that would be 10 minus 4, which would give you 6 on that example. And that's what the high value is estimated doing the same thing, except instead of subtracting, we're going to add. So we're going to do the mean plus 2 times the standard deviation. So each standard deviation was 2, so 10 plus 2 times 2 would be 10 plus 4. So my range estimated would be 6 to 14 according to that data. Okay, so we can estimate the standard deviation if we know the range. We can estimate the range if we know the standard deviations. All right, y'all, so here's the thing. That was pretty much the lecture for 6B. So all that's due this week is really the support and 6B homework. And there might be a quiz. I got to look and see. So you know how to do technically the standard deviation, but next class I'm going to work problems out of 6B homework so you can see what they're talking about on the box plots. So we'll actually find the box plots with the low quartile, high quartile, and all that fun stuff. So tonight, if you wanted to do anything, I would just probably really focus on the 6B support. If you got support. So I think some of y'all didn't have to do support, but I think most of you do. So, oh, that's a talkative little lecture there. So, y'all think y'all can knock out the standard deviation?
Yes.
Well, I'm hearing some yeses, Dana. I'm trying to see if my chat's lighting up. So you only have 2 of those. And like I said, the first one was doing what? Square root. Then you had to do the mean and median. Then you had 2 problems doing the standard deviation. And maybe you can get to probably the first third of the 6B MR homework. But if not, don't worry, because that's next lecture definitely. Also Thursday, I'll start talking about y'all's project. I sent y'all a file one day last week for a stats project. The main thing you want to do the first week is try to find anywhere from 15 to 25 people you can survey and ask them a question. Okay. So not too bad. Y'all got Facebook, Twitter, and all them fun things y'all can get people to respond to, right? So it's not too bad, and we got a little time to do it. I probably won't have this one due until about 3 weeks from now. And what you're learning now is sort of the stuff you'll see on that project, okay? So I will definitely get more into that for Wednesday for y'all. So y'all, main thing today was the standard deviation and the box plot. So I'm going to work a lot of examples Wednesday showing y'all those box plots, okay? But once you get them down, they're not bad at all. Okay. All right, y'all, and I'll start trying to get them financing the car projects. I'm starting to get them graded. So as soon as I can get your class graded, I'm going to upload them grades for you, okay? All righty, so I don't think I got anything else.